Hi, so now we'll be talking about the test procedures for the power subsystem. So this is basically the layout for the power subsystem where we actually convert AC to DC using a laptop charger, and from that onwards we have a power board which actually supplies or distributes power to our other components. So MPPT is our maximum peak power tracker that basically optimizes whatever we get from our source. After that, although this is something which is optional, but like in case we do add portable batteries, so this will ensure that batteries are charged in proportion and to maximize the battery life. Further, we have this DC to DC converter which actually provides different rails with different voltages. So one is 3.3, second one is 5 volts, up to 5 volts, and then we have this variable 9 to 15 which depends on the motors which will be the conveyors use. So what happens is some of the components will be working on 3.3 because components work on different voltages. So for 3.3 we are running some sensors like temperature to make sure that components like microcontrollers do not get heated. So we want to monitor the temperature ranges. Also we have this LED lighting which is part of the IR system, so we are ensuring that everything is safe. So now the test we will be conducting on this system is basically this conversion here. So when we convert from AC to DC, we want to make sure that we have a fuse and the circuit doesn't blow when we are trying to distribute the power. Also, if we do add the batteries, we want to make sure that batteries are getting charged properly and there is no problem, and we have maximized the performance. Also, we'll be conducting a test to see if how much time does it take to charge the batteries. So that will be really important because we don't want to spend a lot of time just charging the batteries. Another test we'll be conducting is to measure how much voltages are available on these outputs where all the loads are connected. So we want to ensure that there is no power surges and we don't blow up our components. So we want to ensure that at all times the voltages supplied are within the range mentioned in this diagram. Apart from that, we'll be conducting another test where we'll be measuring how the sensors are operating and are they getting the proper voltages or not. In all the variations or in case of any failures will be just based on what are the differences in the voltage outputs. If it's within 10% range, we are okay, but if it's more than that, then we'll be failing the test, and then we have to start all over again with the power tests.